session a tiny bit interactive. Feel free to grab the pizza and beer and other stuff. So the theme of this event, so I call it Chautauqua. So, I talked in the past to some of you because you hate the famous fancy names that come up for stuff, but in the 19th century, people didn't leave their village or home they were in because you couldn't get very far, and adults wanted ongoing education. They knew that people were going to exotic places like Africa, and they didn't learn anything about it, and they felt that they'd lost something. And in this town in upstate New York, they invented basically a circus for learning. They called them Chautauquas, and they went on the road. So to your town, there would come a Chautauqua, and you'd buy a ticket for a nickel, and you'd get like a day's worth of lectures for a nickel, or you'd buy 15 cents, would get you 3 days worth of lectures. And they'd have a speaker come in and talk about Africa, Australia, places, things, poetry, philosophy. And so for me, after I left Sandvine, I kind of missed that. We had this culture of these lunch and learns, and with a 1,000-person company, there's a lot of stuff people were learning they were teaching about. And I'm like, me and a bunch of other people I know, we've all out in the diaspora starting our own companies and stuff. We all know and trust each other. We're investigating more or less the same stuff. Once in a while, let's get together and share it, and I'll talk about this, and he's using something similar, and we can, we trust each other. And it's open to anyone, and now more than half the people are people that I don't know from the past. I'm going to explain today a little bit. This is something I've been working pretty hard on for the last month and a half or so. So one of our customers, one of their applications, they paid for a deep commercial pen test on. And as you might imagine, there were some flaws that came up. And so one of the challenges we gave to ourselves is get rid of all the flaws in the platform, even if you don't have to change the application. And so that's something that I learned is how to do some of that and where it goes. So Web Security 101. So some of you know this really well, some of you don't. I'm not trying to talk down to you if you think I'm talking too much, but in a nutshell, what the consumer says is, do what I want, and that's it. Nothing more, nothing less. Trusted platform. I opened my browser, I went here. It's all that should be happening. There shouldn't be any crypto mining going on. There should be none of that stuff. But there's so much active content. Back in the day, they tried to get like ActiveX in there, and Java, and Flash, and even today, there's more. SVG gets hammered, XML, JSONP, CSS tracking pixels. It's a lot more complex than people think. And does anyone recognize this? Anyone? Sammy's my hero. Fastest replicating worm in history. So Sammy, who did a little bit of time for this, unfortunately, which I think was a little unfair. This was MySpace, and he just changed his profile. So this tiny little bit of script would evaluate when somebody went to the profile. And what it would do is you would add Sammy as a friend, and then it would change your status to Sammy is my hero, which I think was relatively harmless in the greater scheme of things. The FBI took a different opinion. But this is all it took, was this tiny bit of text. And the reason all it took was that is ultimately he was able to call eval inline right in there because this website didn't use a feature called content security policy, and it either did and used allow unsafe inline on, or more likely it didn't. And that's all it took. And Sammy was my hero. I saw Sammy speak once. He's a great speaker. I don't think he knew this was setting him up for a career. I think he was just a guy that was trying something out on MySpace, but he got pretty famous. The tools of the trade. Does everybody recognize these names here? So the first one, very, very complicated to use, very simple to understand, but very complicated to use, called content security policy. In a nutshell, I serve you a website. I assert what that website is allowed to do. Where can it load images from? Where can it load CSS from? Where can it load styles from? Can it do stuff inline? Why do I do that? Because my website includes resources from a third party, and they include resources from a third party, and they include resources from a third party. And along that chain, unpredictable third parties arrive, like advertising. And if I want to get you, I can buy targeted advertising that will eventually hit you, and I know that you'll execute it. And what I want to do is, as an owner of the site, I have a duty to my brand to make sure that people don't get infected from my site. And that's really why I care as a site owner, as I don't want, oh, somebody used this website and therefore they got infected. The second one is colloquially called XSS, but these are cross-site scripting, a little bit older. And this is intended to prevent clickjacking, somebody embedding one frame inside another. It's been largely superseded by the first one. The third one is also unbelievably complicated to get right. So cross-origin request sharing. So the idea here is the modern architecture of web apps is they use APIs. And instead of the old architecture where the web app was thin and the back end was thick and it did a bunch of stuff east-west, now you encourage the front end web app to just go and talk to all these APIs. But who knows what that thing's doing? Is it exfiltrating data off my hard disk and posting it back home? Like, who knows what's happening there? You want to put a bit of protection in there. Sometimes the protection is from the API writer standpoint. So and a good example there is a company called MailChimp, which I use. And MailChimp, like a lot of things, it allows you to get an API key. And they absolutely forbid, via CORS, you using it the exact way you want. What you want to do is embed it somehow that it ends up in your WordPress, so it ends up in the user's browser, so the user can cause the email to be sent via MailChimp, because it's so much easier to do. But as soon as you've done that, they have your API key is now in the user's browser, and any user that scrapes your site has the API key. So MailChimp knew that people would be wanting to do this, so they just flat out block it with CORS. You cannot request from their API from a browser. It just won't allow it. And that's a simple seatbelt because people try to do dumb stuff. Strict transport security. It's 2020. TLS certificates are free. Not only are they free in a monetary sense, they're also free in an operational sense. Let's Encrypt and Acme made it so that everything can have a certificate for effectively no cost to people, no cost to dollars. There's no reason anything is not encrypted. So for our domain, I went one step further. We put our domain on what's called the preload list. So I encourage you to all do this. If you go to preload.org, you can take your site, your domain, you can put it in there. That instructs Mozilla and Chrome to ship a copy of a list that you're in it. They will never go to your site not encrypted. That means your user can't be downgraded. Unfortunately, it means if your users go to some restrictive regimes, they might not get to your site, but that's actually what you want. Your next best alternative is in your header, when you serve out your traffic, you send it this thing called HTTP strict transport security. You're instructing the browser, once it's seen that once, memorize it, never come back to the site on non-SSL, never get downgraded. You'd be shocked how many people have paid for a good certificate or set one up and then don't set this up, and they end up with their users still using HTTP or having mixed content. You know, things like, even like big name sites like Canadian Tire do this. It's a real problem. The TLS setup, so this is another one. This is getting a lot better, but historically, TLS was pretty strong, but a lot of people would forget, or they'd have a weak prime, or they wouldn't generate their own Diffie-Hellman because they were lazy. Anyway, they would get it set up wrong. And one of my favorites, it's really obscure. Does anyone know what CAA is? DNS.
This is where you set up which fees are allowed to issue certificates.
There you go.
I thought it was a car insurance thing.
Yeah, Canadian Automotive Association is a different organization. They're meeting down the street. It's exactly what he just said. So I put a text record, or actually I put a CAA record in my DNS, and I say, I only use Let's Encrypt. So if somebody's signing me from Symantec, not allowed. That's because Symantec isn't allowed to sign certificates anymore. They lost their license. They did such a bad job of it. Other people, they're worried about some of the CA authorities not being that strong. If you know you only sign your site with A and B, you can put a record in there to say none of the others are allowed. And it's very simple seatbelt.
But if Let's Encrypt is taking over the world, then what good does it do to say that I only trust?
Well, I got two answers to that. First of all, I think Let's Encrypt is doing a much better job of transparency and security than the other CAs. They publish a transparency log. You can go and see any domain that's had anything signed ever. It's in there. Yeah. And in fact, it's a really good resource. There's some commercial tools you can buy that watch it on the fly. And if you're worried about your brand being spearphished, so let's say you're foo.com and you see people getting fo0.com and they're getting a certificate from it, it's actually a good protection scheme. But every single cert that everybody's ever issued on that is in its transparency logs. And you can see them in real time. They have public audits done frequently. The board of directors and the executives there are from enough different organizations with enough interest in security. It's unlikely, in my opinion, there's shenanigans going on there. Like the EFF and Mozilla, I can't think of two organizations less likely to condone some sort of fraudulent shenanigans. Like there's no commercial money to be made here. It's a US not-for-profit. I'm not saying the others are bad, but some of the others are integrated with things that you might be surprised about. Like VeriSign is often integrated with some of the governments around the world of the telecoms, and you might be surprised or worried about that. If the only thing left at the end is Let's Encrypt, probably that's okay in my opinion. The other thing is Let's Encrypt doesn't offer long duration certificates. That used to be a hassle. Like everybody wanted to get a wildcard cert good for 100 years, right? Because, oh my God, who wants to be copying that to all the servers? Who thinks wildcard certs are a great idea? It's a great idea, except for the fact that if you lose that, you are screwed. Because anybody could make anything happen. So with Let's Encrypt, it does support wildcard, but you should never use it. You get it for every single thing. Here's another thing. You went and bought a shiny new domain name, right? You're going into business. The first thing you're going to do is go online with that the next afternoon and start doing e-commerce, right? Who had that domain last? They could have a certificate that's got a little bit of time left in it. You're supposed to hold it down for a while. If we issued certificates for 3 years, you'd have to hold your domain down for 3 years. So my domain, when I bought this domain had been dormant for a few years, so I wasn't too worried about it. But theoretically, somebody had registered it and then unregistered it the day before I got it and had a certificate still there. The CAA would be a bit of a seatbelt there. I have a thesis, and this is controversial. If the public website of a company shows up as weak on these things, it suggests that there's a culture that doesn't really care about security that much. Now, this could be false. You could argue, my public website doesn't take any information, it's just read-only. I don't care if it's HTTP or not, it's totally public. But I think everybody's public website has enough active content on it. They got a tracker from a third party, they're using a CDN to get jQuery, et cetera, et cetera, et cetera, that they have some risk there. At a minimum, it's a risk to their brand. If you get hacked through that website, then my brand is at risk. So I think I've got that risk there. So even if my website is just content, you should also be worried about being defaced. Like who would want a swastika on their public website? So you should think about that. So this is my argument. This is my thesis, is a site that doesn't have these indicates deeper problems in the organization. So does anyone remember this hack? This was hilarious. So does anyone know what this is down here? This is a whois record. And this is an SPF record, which is how you tell people not to spam you. And a lot of people use whois, so they use it to look stuff up, who's got that domain. And I'm not sure what peniscorp.com is, but I know from a little bit of past experience that this is Rickroll. So you do a whois on this guy, and you get Rickrolled, which again, like the Sammy thing, is actually kind of hilarious. Until you realize that it might have been something other than Rickroll that's in there, because you're executing JavaScript in the DOM of that user just completely wide open and naked. So content security policy, very simple to understand, very, very difficult to implement, because the tree that you load is so large and most people don't know what's in it. So the idea is there's a new header, and in it you say, who do I allow to make a frame out of me? Where am I allowed to get images from? Where can I load CSS from? Where can I load JavaScript from, etc. It sounds really simple, and it can also report violations to the server, which is actually kind of important. It's your server. You would think you would test this app, but who knows that someday one of those downstream things doesn't change the behavior. At least you want to maybe get to know. It tells the browser where it's allowed to get stuff from. So if we look into a bit more detail, you've got this concept called self, which is me, where I am star. HTTPS means anything that's secured, or a specific URI. So connect source self means I only load JavaScript for myself, which is a good strategy. And these are all the different things. So the reason it gets difficult is, oh, I'm sorry. For anyone who reads Chinese, what that says is IR motion detected, because it's a laser projector and I angered it. So if you get your hands in this area, it gets mad because of blindness. That's because you don't want to lean over. It's a laser, right? It gets really hard to do this because where do you get your images from?
Laser pointer for the laser projector.
Yeah. Where do you get your images from? Well, you get them from advertising. You get them from, you've got an RSS blog roll you've got with a friend. Like it's a big list. And as soon as you put star unsafe inline data : in here, you basically defeated the purpose. It's like putting a lock on your front door and then hanging the key beside it and putting one under the mat and putting instructions up that there's a key under the mat. So really it comes down to the document basics. So the base URI, what can be a base, etc. So I guess what I'm getting at is I found this very difficult. I don't know if the rest of you found it difficult, but even like things like the form action, you know, I use MailChimp. MailChimp changes their form. I don't know from the origin what that's going to be. So I just say star.mailchimp.com. And tomorrow they switch to Cloudflare. So now I need to be cf.mailchimp.com. And the website would break. Has anyone else found this one hard to do accurately? Like it's easy to just make star for everything.
So I haven't used this at all. I haven't heard of it before, but can you then even serve ads on your site? That sounds like it's a thing you can't do anymore. Because
Well,
this would be too cumbersome.
I don't serve ads on my site.
Correct. But 90% of the internet wants to still make their living off of ads and tracking.
You might need to make that a frame that has different rules than the rest of the site. You might need to have something that's rendered server-side to help you out that's a facilitator. You might have some sandboxing in there.
Can you say, like, within this div, you can do terrible things?
No, but you can sign stuff. So you could say, I will load things with this hash that's called sub-resource integrity. And I guess that could allow you to load a piece of JavaScript with that SRI. I don't know how you would do it.
Are ads, like, don't ads typically come from specific CDNs? They're like specific to that ad provider?
No, it's federated.
Okay.
So yes, if you use only Facebook as an ad delivery, but most ad delivery, you know, I sell this banner, the guy I sold it to then turns around and bids it to 9 people. They turn around and bid it to 100 people. Who knows where that's coming from?
Proxy through the seller. It actually is like.
No. I found this extremely difficult to do on our WordPress site. I found this very easy to do on our Angular apps that we have because 100% is just self. It was easy. So I think if you have a web app that you've developed, you have a lot of control. But as soon as you start to have dynamic content, as you say, with an ad or part of the internet ecosystem, it can get pretty tricky.
Or even just downloading a JavaScript library off of the internet for like a font.
Well, fonts. So let's say you use the Google fonts. So you're going to put, so if I was to show you my policy, we have gstatic.com allowed in there. Technically, I'm outsourcing some stuff to Google. Google could theoretically put something malicious on gstatic.com. I think their brand name is worth more than my brand name. They're unlikely to do that. Would I put Dewey, Cheatham, and Howe on there? I don't know, but I had to put gstatic.com on there. Other CDNs, a lot of people use jQuery from a CDN. So you do one of two things. You either put the domain in the list there, or what's better is you use what's called sub-resource integrity. The sub-resource integrity is they have a hash of it, and you put in, I will load jQuery with this hash. So you load it, you check the hash. If it's not good, you chuck it. And now there's no shenanigans, and it doesn't matter where it came from. That doesn't work for ads. But
For jQuery, as soon as there's a security update to jQuery, you're like, I need to use the new jQuery.
well, you want to pin your site. So you'd have to pin your site. So in Angular's tooling, they make that very easy. When you do ng build, it does the signing of everything. But if you have like a WordPress site, I don't know. You'll never go wrong if you make your rule default source self. If you say that, I guarantee the only things that load are coming off your disk. I guarantee your site looks like an old school GeoCities site. But it'll work, right? So if you've got some corporate website that is just a forum for people to enter their vacation time in, you might just cut and run with that because it's going to be fine. As soon as you get into, so WordPress is an example, WordPress requires you to have unsafe eval and unsafe inline. If you run Angular.js, the old school Angular, they need that unless you put this magic ngx-csp option on, which nobody ever did. And it's because they actually, basically they do string equals sprintf blah eval. And they do that constantly, which is exactly how, self-modifying code. Remember being taught that in school? Did anyone use the words good or bad at the end of that sentence? But that's what it is, it's self-modifying code. You load a page and it wants to do something different, it just changes itself. And it calls eval on it. But you don't want that because it means that the bad guy can do that. And that goes back to what Sammy just did there. Sammy called eval on a string that he just jammed in there. And because you opened Sammy's profile, you saw that, now it's in your profile. Now your friend sees your profile, now it's in their profile. And Sammy is everybody's hero. My argument is, once you start setting this up, you're so much better off than everyone else because you've made an attempt at it. If nothing else, I would say set object source to none because you're not going to be letting people load Flash or Java objects or ActiveX, right? There's no other objects. So why would anyone let an object load today? So I would set that one to none. If you're using an Angular, you can use the sub-resource integrity, which is the hashing. And you can use what's called ahead-of-time compile. So it compiles it and it checks it all, and it's all in your thing. But if you're in WordPress, you've got to suck it up. My rule set for WordPress, it wouldn't fit on this screen. It wouldn't fit on 3 of these screens. And that's in every header. Like, that's chewing up bandwidth. But otherwise, you're writing a blank check to some JRandom hacker, and that's your signature on the bottom. It took me forever to put that together in GIMP. XSS, this was another big one for me. So I'm leading up to, we had to work around a problem with an app that we didn't write, and we weren't able to change the source code of the app. So there's 3 main things for XSS. The first one says don't guess MIME types. So browsers used to be super helpful. The IETF invented this thing called the happy eyeballs policy. That's exactly what it sounds like. The strategy is, if the user sees what they want to see, you must have done the right thing. I talk about it with IPv4 and v6. You're like, does the site have both a v4 and a v6? I don't know. Try both, and whichever one works. Happy eyeballs. Unfortunately, what can end up happening is the browser could misguess, and you could feed something back that you think would be rendered inside the browser, but it actually opens. It's pretty touchy today. It actually opens Excel, and then it starts something in there, and you're like, what's going on? Because you don't know what the user's got installed on their desktop. They might have a different handler for the MIME type. You send back what you think is a very innocuous text/CSV, and it opens something that they don't want opened. So by setting this, you're telling the browser, look, I will tell you the MIME type. If you don't know what it is, don't do anything. The Xframe options, this is another, so think about, you've got a website, it's beautiful, and you've got your brand in there, and you've got to log in, and it's perfectly secure. If you allow someone else to embed you in their iframe, they can run stuff in their iframe and embed you, and they can watch every keystroke, and your users will never know. Going back to that spear phishing, the user will open your page and think, it's all good, I entered my username and password to work, my bank balance is okay, and then slurping sound as your bank is siphoned out. So you want to put on this Xframe options to say, look, personally, I don't think you should ever allow your site to be embedded into something else. I don't know why you would, but if you have a legitimate reason, at least you can say it here. Sorry. And then the XSS options, this is basically no longer used because it was only used in Internet Explorer. Chrome and Firefox didn't adopt it. Internet Explorer died, became Edge. Edge died and became Chrome. But some organizations still have Internet Explorer needs, and therefore they would put this on in addition to the CSP, which is even more so if I were you, this would be my headers. No sniff, deny, block. You'll never go wrong with that, and unlike CSP, it's really unlikely to break something. All you're basically telling the browser to do is, if I didn't tell you what the content is, then it's nothing, just open it in the browser directly. Secondly, no one can embed me in a frame. And third is, if you think there's clickjacking going on, using your internal heuristics, then just block it. Internet Explorer has some internal heuristics about that. Yeah, so it's no longer used. The other browsers didn't pick it up. They made it explicit in CSP. But in this case, it's implicit. Internet Explorer has a behavior set. If you set to block, you turn it on and set it to block, then it'll run. For a browser that a lot of people unfortunately use.
Just kill us one for you're good.
Also gets rid of it.
Where do you configure this? Like,
These are all headers from the server.
so how do you put this on your WordPress site if you're not using it?
So in WordPress, there's a plugin for it that I use 2 plugins. One's called HTTP headers. No guesses what that does. And no, it actually, you configure it in the WordPress interface because the plugin allows it to set arbitrary headers. The second way you can do it is if you have control of the server, you can change your Nginx config or whatever. And the third way is, I guess, if you're going through a reverse proxy, you could augment it on the reverse proxy, which is the approach that I'm talking about tonight implicitly. That's what we had to do. Well, no, let's say you've got a Docker container that serves it, and then you've got another ingress in front of it that you could add rules, which is what we're doing. You've got a web application firewall or something. But if you were using WordPress, it's really simple. There's 2 plugins, one's called HTTP headers, one's called Content Security Policy, CSP. You just go in it and you start typing until your WordPress stops breaking, and then it's good. And then the next thing is How do you test it? Well, the thing after the next thing is how do you test it? CORS. I really struggle with CORS. I do not understand how anyone could legitimately use CORS. I gave you the example of MailChimp's API key. That's a legitimate case to just block everything with CORS, which it's really good at. CORS doesn't allow wildcarding. So for a CORS header, you get to say, it came from me or it came from anyone. That's it. So you can't put a list in. And this is where your API is. So let's say you're making some API. You don't know who's calling you, so you got to put in star. If you put in anything other than star, you block everybody. So I don't really understand how people can legitimately use it in a great scheme. However, the MailChimp example was a good one. They didn't want any browser ever calling their API because the only thing they gave was an API key, and they knew therefore the browser would have to have it. If your site supports like a dynamic login like OAuth 2 or OpenID Connect, and you've got a one-time use JWT or other token, and you're putting it on as a header with X-header authenticate or bearer token authentication, I think you have to set this to star personally. There is a third technique, which is, I would call it controversial, and it's the one we use. So we use a technology called Istio, which is a really magic service mesh reverse proxy. And what it can do is, since this can only be star or me, it just lies about me. It just changes it. So if you call it from A, it responds back and says A is good. If you call it from B, it responds back that B is good. How is this different than star, you say? I'm not sure. It makes me feel better. It mostly means you pass a security audit with somebody who says thou shalt not allow star. In theory, I could write some Lua code and I could say A and B but not C, and I could actually, because it can feed back something different. And my love of Lua is growing, but I wouldn't call it large. But it's growing. Okay, it's coming up in a minute, I promise. So the cross-origin request squaring. So you basically, you put this header on, access control allow origin. Like I just said, if it's not star, be prepared for everything to break. If it's same origin, your API has to run on your web server, back to the days when we didn't have distributed APIs. If you have an API that uses bearer token authentication, I think star is reasonable. If you use an API key, I think you have to deny everything. Otherwise, people are doing something unsafe and you're being nanny state and telling them not to do that. If you've got Istio, you can convince it to dynamically set it. This clever looking person with the blue shoes is dealing with the sensitive data there. Took me forever to draw that. So let's do a little case study. Everybody remember Marriott? 2018, they were in the news. 500 million users breached. Passport numbers, Visa card numbers, home addresses, the person you checked into the hotel with, even if they weren't the person you were married to. The sort of stuff you want out there. The CEO was called to testify before the US Senate. You'd think this would be something that they would remember. Like, you don't get called there every day. And you're on the wrong side of the witness stand, and they're actually allowed to call witnesses in this case, unlike another one. And they're yelling at you. 500 million people, how did you let this happen? Who did you have as a CIO? Was the CIO a music major? Thank God not for them, it was for the other breach, not a music major here. So you gotta think that that CEO came back home and just yelled at the security people, right? You gotta believe that people were scurrying around forever to fix things, right? What's the first thing you're gonna fix? What's the first thing you're going to fix if you're Marriott? Marriott.com, right?
Lightning doesn't strike twice.
Well, Dave could be right. So, yeah, it's working perfectly, so let's leave it alone. So, first, this is the map. If you go to Marriott, every one of these dots and bubbles is something your browser fetches. That tree is wide and deep. Going back to the CSP, the guy that's told, okay, codify all this in that little rule set? Eek. Can they all be trusted? I don't know, but we're as strong as the weakest one of these. And some of these, we've angered the laser gods again. No, we don't want that.
Please translate this thing.
Or just like Google Translate. It's mostly English.
Okay, yeah, don't worry about that thing. When we turned it on, the first thing it said in English is, what was it? Keep working, allow welfare. And then it called me something stupid. Or Mr. Stupidhead, what was it? Anyway, it's really weird. It's a great product, actually, so just don't let it on the internet. So you're Marriott, your CEO has just testified before the US Senate. 500 million of your customers have had basically everything of their life exposed, everything needed to open a credit card or anything in their domain. You got home, the first thing you did is you scanned your public website. I scanned this yesterday. They got a 0 out of 100. They got an F. Now, this might be a little unfair. They might argue, as you might argue up front, the public website there's no active content, there's nothing, it's all public, who cares? But Marriott doesn't want any evidence of impropriety now because of all of that. And they came home and they did nothing. No content security policy. The cookies are not set using the secure flag, which means the JavaScript can get at them. They've used HTTPS, but they didn't turn on the redirect, so they're not forcing the user there. They're not pinning their keys. They are using cores, which is really hard. They don't have the sub-resource integrity, et cetera, et cetera, et cetera. So my argument is, you're Marriott. I got to believe this is the easiest thing to fix, because I don't know what the rest of those systems are, but they could be really complicated, right? There's point-of-sale terminals from many vendors. There's AS400s involved. There's contractors from people like Accenture and so on. They got their hands in your pocket. Who knows where that trail leads? But at least you own this. I would be fixing up this, if nothing else, so that people wouldn't say you did nothing. My argument is, if you have an organization that the front door is locked with a stick-on lock, probably there might be problems elsewhere in the organization. I could be totally wrong, this could be totally unfair. However, this was probably the easiest thing to fix. Because the only downside to getting this wrong is a little bit of the page wouldn't load. You're not talking about your e-commerce and all your other stuff. And again, think of how embarrassing it would be to have your CEO called on the carpet like that.
What site do you go to generate, so that I can generate that terrible report for my website?
I'm glad you asked. Who wants to try an experiment and do a live and interactive? We won't use your site because it's embarrassing, I'm sure. But we can. Okay, so now, give me something that you think is a reasonably secure site. Canadian Bank or something. Manulife? Let's do something that no one in the room has previously worked at. So, CIBC? Anyone got an objection to that? Oops, sorry, wrong thing. So, observatory.mozilla.org really simply will let you do this. So, Google.com is actually quite strong. It's really quick, the scan as well. So we'll just quickly do this. It's only a few seconds. So CIBC got a 0. Google gets an A. So Google implemented pretty much everything. Same rationale. They didn't really try.
So Mozilla people wrote this tool?
Well, so technically this tool is public. The source is available. You can go run it on your own network without using the public one. It's a very simple Python thing. Anything that's under the Mozilla brand in their open source, you have to pass this. So let's say that you write, I don't know, something that's under the Mozilla brand. This is their internal QA, their CI for it. So somebody asked me to do gmail.com. So it is possible to be strong. So there's Gmail. So there's a few things. They have implemented this. Remember I said you're better off at least trying. They had to turn unsafe eval on. Probably they don't want to, but there's probably some legacy reason. They fixed their cookies, they fixed their cores. It is possible. So Qualys is another great tool. So I heard Qualys mentioned there. It's a little slow, unfortunately. But Qualys, it's not as web friendly. Qualys is how you check your SSL certificate security. It's how you check whether you've set up your encryption properly. And it's really simple to use. And it's a lot more readable on a desktop. But you just type in your domain name. 2 seconds later, it comes back and it says you got an A, a B, a C. Everybody should get an A. There's no excuse on this one because it's not hard. There's no compatibility issues. So this one is really simple for people to pass. So those sites that don't pass this have a really structural issues here. No. So Let's Encrypt is the certificate, but not the encryption parameters. So this site here is A+, and anyway, it goes through. What Let's Encrypt does is it, I wonder if I turn it sideways if it's a bit more readable. Oh, look at that. You have control of which ciphers you allow, which protocols you allow. This site only allows these. There's a really great list also by Mozilla which says what the recommended set is. And they have 3 sets. Basically, you want to go with the intermediate. Nearly every device will work perfectly. And there's a strong one, which is for people that need PCI compliance. There's an intermediate set, which is highly compatible and highly secure. And there's a crap one, which is if you have legacy devices. SSLLabs.com. And again, the tool is available. You can run this yourself privately offline, but it's really simple to run. So you can see in this particular case, we've got the compatibility layer set. We have actually broken IE 11 on Windows 7. So because I chose to do that, the trade-off is I could have allowed that at the cost of reducing my security. Let's Encrypt has nothing to do with this. So this is a choice that I'm able to make because I don't use that.
So then this stuff, these parameters,
Yeah.
they're set on your web server?
Yes.
Okay.
So when you set up your web server, you're responsible for 3 basic things. The first is you create a one-time prime number called your Diffie-Hellman prime. If you found one on the web or if you use the same one on all your servers, you did a bad thing. So you make your own. Second thing that you did is you gave it a list of cipher suites and versions of SSL you allow effectively. As of January 1st, TLS 1.0 and 1.1 are deprecated, and everything before it is removed. So as of January 1st, TLS 1.2 and onwards is all you want. Some people have reasons to use the others. They're not technically yet insecure. People are just suspicious because they're old, but they haven't actually been broken. While you're setting that up, you see how I've got these mouthful of alphanumerics here? The Mozilla site will tell you exactly what you want to put here. So this is saying I allow elliptical curve with Diffie-Hellman, with RSA, with AES 256, GCM, SHA-384. That's a specific suite. Every client has a different thing it supports. I need to have more than one here because like Apple iPhone might not support, they might not support Cha-Cha-Cha 20, for example. And they might only support AES. Theoretically, I don't know that for Apple.
You want to sort them too in specific order.
Also, yeah, that's the other thing is the order matters. You want to put the strongest ones first and the weakest ones at the end. With TLS 1.2 and 1.3, it's much harder to trick the server into using a different order, which is called a downgrade attack. So you're responsible for setting that up. It's not super complicated. Compared to the other stuff I talked about, this is a cakewalk compared to the CSP because it's completely compatible and it'll just work.
But when I install like Ubuntu and just go apt-get install Nginx or apt-get install Apache, does it not do this stuff right for me, or am I still?
Yeah, so the third thing you need to do there is you need to put a certificate in that. Ubuntu, if you install Nginx, will have an opinionated install of how it has the SSL certs. If you enable SSL, it will use its opinion. It's likely that its opinion is good. It's not a guarantee. I would double check it. Again, there's a trade-off between secure and available to the number of devices. They may have gone one step further down that than you are comfortable. So we use the Mozilla intermediate profile, which is highly secure and highly compatible. But my trade-off is, so we work on Android 4.4. That's way far back in my opinion. We could have gone with their super secure one, which would knock it out. We do not support IE 11 on Windows 7 or Windows 8. I am okay with that. Some people will not be. As a consequence, it's possible their defaults are weaker, and it would be a decision you'd make. But it's likely correct. Okay, so we will go back to, oops, here. Oops.
And so these reports, when I run it on my web server, tell me what to fix?
Yes.
Or they'll just say I'm a terrible person?
No, they're actually quite good at, certainly there are ones out there that just say you're a terrible person. So here's an example. This one here, up there, that's their first recommendation. Once you do that and rescan, it'll give you the next one. It's very explicit. If you mouse over these, it gives you a pretty good understanding. And if you click on this link, it takes you to the documentation that explains what to do. So this one is hyper actionable. This one, the other one we just did with the Qualys, is pretty actionable. So your main issue there, if you don't get an A, it'll tell you what you did wrong, and you'll have to go figure out how to fix that in your server. So we just covered why those people might have done a better job. Keep going into their site. It gets worse. The browser can be encouraged to keep a bunch of state. And as an app developer, that's a really convenient spot to store things like your authentication credentials and cookie, your authorization keys and API keys and stuff like that. And these cookies haven't been set. They can set them to what's called HTTP only, which means only the browser can read them. Without setting that, your JavaScript can introspect them. So it means that web page that wanders in with the ad can snoop around on these cookies. And then it can turn around and use them to do something bad. And we don't really want that. So here's an example. We just opened up the cookies tab on it, but you can see this in your developer tools. All but 2 of them can be snooped with JavaScript. Nearly certainly they want none of them to be snooped with JavaScript. So we just talked about the SSL Labs thing. So the CAA record, we talked about that a little bit earlier. It's basically a who can sign my thing. The second thing is, there's another site I really love called internet.nl. It's run by the Dutch government and a bunch of volunteers there. Super simple. You just type in your domain name. It tells you a bunch of stuff. The most interesting thing it tells me is what's called DNSSEC. DNSSEC is a way to sign your DNS so that other people can't change it. But it tells you some other things about your site and whether it's well set up or not. Fuck. .ca has DNSSEC. They were one of the earliest domains, but not the earliest to have it. Not all the registrars support it, though.
Is DNSSEC important? Conflicting things like.
Here's the way I would phrase it. It will never hurt you. It will never do anything wrong, and it costs you nothing.
Except all the time it takes to set it up.
It's a check mark. Like literally, for me, it was a check mark. Is it going to protect me from a lot of stuff? No. Like if I got everything else done and didn't have time to do this, I probably wouldn't stay up all night wondering. So I wouldn't do it first, but it's so easy. And again, somebody's going to come in and audit you. Do you want to have one black mark in your report that you could have gotten rid of? Why not? Okay, so I learned all of that because I had an application that I was trying to get going on the public internet in a highly secure fashion that I couldn't change the source to, which had some of the flaws that I've talked about earlier. So there's a special type of Band-Aid that exists. And I don't think this should be your go-to thing. If you own the app, you should fix the app. Why put a Band-Aid in the middle? But sometimes the Band-Aid is the only solution available to you. And it's a special type of thing called a web application firewall. And there are very expensive web application firewalls, and there are very good web application firewalls. And there are probably expensive good web application firewalls. And it's a magic regex unicorn that exists. And if you thought CSP was hard, you haven't really got into hard until you get into this. But you're going to have a sideload of Lua with a lot of JSON and some regex. However, let's dig in. The one I'm going to talk about is called Lua RestyWAF. Resty, OpenResty, is Nginx with Lua. So it's got a bunch of features around it, but it is Nginx. It's not a different thing. And somebody's written this thing called Lua RestyWAF. It's really fantastic. Cloudflare uses it. So Cloudflare, I don't think they wrote it, but they have contributed a ton to it. And wow, if you thought the earlier stuff was hard, it gets really, really hard when you've got maybe 800 or 900 lines that look like that for each feature of your website. You could easily have 40, 50, 60K. More slashes are better in regexes. It's a proven fact. Okay. It's tough to maintain. It's powerful. It's dangerous. You know, it's like having a drunk monkey with a chainsaw and a machine gun in the backseat of the car with you. If it was hard to, yeah, if it's hard to write, it should be hard to read. Yeah. It spirals out of control when you realize that some of the things you're trying to get are also themselves URL encoded. But here's an example. The top bit there, we specify what MIME types we allow. If we couldn't control our app, we can prevent it from emitting something we didn't want, as an example. I'll let you research that on your own because it's super complicated. It implements something called ModSecurity, which is sort of considered the gold standard of something called the OWASP Top 10. The OWASP Top 10, you can't implement all of them technically because some of them are be better people, but ModSecurity for years was the standard for how to do this, but it was really difficult for people to use because it only run in Apache, and then it was kind of half-assed ported to Nginx. They've done it in a really clever way. There's a JIT with this Lua thing, so it's actually really efficient. And it covers off a bunch of things like malformed headers and a bunch of problems that have occurred in the past. And you kind of sort of sanitize all that out of the way and you're left with less. So here's my call to action. In 5 minutes, we were able to assess a very simple external aspect of a security culture of a company. We could have picked anybody's website. We picked Gmail, it looks pretty good. We picked a bank, it didn't look so good. We picked a hotel site, it didn't look so good. I could be absolutely wrong, but it seems to me that that reflects negatively on the security culture that's there. If somebody can get that wrong, I think they could get other things wrong. So if we each go out of here and we adopt a site, check it and notify the owner, and then we fix a site we own, and then we teach someone about CSP, XSS, and CORS, we'll go far faster than the Wuhan virus. Right? It's pretty good. So that's a call to action. Not literally. So that's the end of it. Any questions? Yeah.
So some of these things were about protecting the server.
Technically, none of them were about protecting the server. Yeah.
Most of them are trusting the browser. And there's sort of a security mentality is that you actually shouldn't trust the browser because you don't have control over it. So you really should fix everything on the server side.
I would argue the main point of what I'm presenting here is about a properly maintained browser, giving it the proper instructions to do the best it can. Because spear phishing happens on the client side, clickjacking happens on the client side. A lot of today's attacks happen on the client side. If I can influence you to open something in the DOM of another page, I can access that page. So a good example, a couple of years ago, British Airways had a big leak. 300,000 credit cards got leaked. And the way that happened is they used a piece of otherwise trustworthy JavaScript that one of the developers didn't have two-factor authentication. A new version got published, got embedded in the page. It could snoop the keystrokes. Yes, you should protect against that on the server, but you should also protect against on the client, and the client listens to what the server says. Because it's not so much the server, but it's the content that's telling it. The content is describing itself. How active will they be? As far as TLS goes, I think both parties are being protected against that. So that man-in-the-middle attack is more likely to be gathering the client's credentials than to do something on the server, I think. It wasn't all that hard to understand this stuff, right? Don't get me wrong, getting the CSP right, really, really hard. And maintaining it, probably impossible. Subject for another day. CORS is hard, but...
I find CORS hard to understand still. Like, it's wrapping my head around the use case. Like, there's got to be something more to it that I'm just missing.
Yeah. So who's going to go adopt a site? Come on. Yeah, okay. So I've adopted a few sites. Some people react negatively when you send them a thing. So funny story, this is absolutely true, and it's funny. A couple years ago, they sunsetted what's called SHA-1 signing in favor of SHA-256. And one of the sites I went to, Chrome no longer would trust it because it had been detrusted. And the the reason I went to this site, this is a great podcast series called Masters of Scale, Reid Hoffman, founders of really big companies explain all their problems. And then people started Airbnb, got on there and so on. It's really interesting. And this woman gets on and she's talking about the company she's built called Spanx. I never heard of Spanx. So Spanx is like underwear that squishes you in. And so I go to their site, spanx.com, because, I don't know, and I get this thing. So I'm like, their site is broken, nobody can get to it. They're going to want to know about this. So I find the spot where you go and you submit like a comment, and I get this very automated trouble ticket back. You know, your ticket has been assigned case ID, blah, blah, blah. So I now actually have a trouble ticket in the Spanx system for, you know. So someday you're going to see me on the stand and somebody's going to bring this up and I'm going to be like, what? But, you know, I'm never going to be prime minister. So plus it's a little bit embarrassing. It's not that bad. So, but anyway, if you pick a site, some people react very positively. Spanx fixed it. Probably they were surprised. Their site worked in Internet Explorer and Edge. It didn't work in Chrome or Firefox because those ones lagged a bit in terms of when they applied the hammer on the SHA-1. Other people, they're like, quit hacking me or go away or you don't know what you're talking about. My security guy's got this. You can't really fix it. It's not your problem. But the ones that are, we should fix because there's no reason not to.
I had a weird, interesting, I hacked together a report in HTML.
Yeah.
It's like, I wanted to produce a file from a test result.
Yeah.
And I embedded the CSS in it.
Yep.
When you download that in the browser, it won't render the CSS.
Yep.
But if you open it as a file, it does.
Yep.
What could be possibly the security risk of not running the CSS that you served in the same file as the content?
So here's...
What I saw was that we had to like set some wildcard thing.
It's the same origin. It's the XSS one that you saw there.
Something like that.
Yeah.
It seemed like it was, the cure was worse than
The reason is that your HTML is self-modifying, so they want to avoid the case where something else modifies your HTML and then calls eval on it.
Like, you know, like Web 2.0 stuff, right? You user created content.
Okay, it was
The same
simply
as
a
my
static.
data.
It was like a static page. It was like old school HTML.
Well,
Table.
yours is, but your browser didn't know. It wasn't that page. It was, hypothetically, you loaded that in a frame with other JavaScript. And that JavaScript could dynamically change this. And it's worried that you're calling eval in there. So for that one, you need to set data : in your CSP, which is the new way to do it. Or you need to set your XSS to same origin.
I had no problem serving CSS from elsewhere.
XSS to same origin, it would have allowed it. In your CSP header, if you'd set it to data : it would have allowed it. So the rationale is the same as the unsafe eval or unsafe inline. You're calling eval on something in there, and it doesn't want you to do that because it's worried that somebody else would change that and call eval on it, so you get SAMI'd. Okay? Well, there's more pizza, there's more beer, help yourselves. And I'm not going to touch the projector again well, it's touchy today.